Hello everybody. If you have been doing programming for a bit of time, you almost certainly know about Python. It's currently one of the most favorite languages of all programmers worldwide and is very much in demand nowadays, and it's most certainly one of the easiest languages to learn. So in this video I am going to give you a beginner tutorial on Python, and we will cover quite a lot of things. So if you do not know anything about Python, at the end of this video you will learn everything you need to kickstart your career in Python. So if you like this video, do not forget to subscribe to my channel. Now let's get started. If you are on Windows, you can go to www.python.org and go to the Downloads tab and click on the button. The version name might be different if you are watching this in future. And save it. When it's downloaded, you can run it. When this opens, you can check this add Python 3.9 to path and then click on install now. And if you see this screen, click on yes, and now you have to wait until it finishes installing. And when it's done, you can click on this option that says disable path length limit and just click on yes. And finally you are done. You can close this. On Windows, you can go to your start menu and look for something called Python. This should open up something like this. Here you can write your Python code. For example, I can write 1 plus 2 and it should output 3. You can exit this by pressing the close button. You can create a file with the extension .py and it should automatically associate it with Python. As you can see, the Python logo has appeared here. Now here you can write your usual Python code and save it, and then you can open your command prompt and run py followed by the path to the file, and it should print the output. Or you can just double click on this and it will run with Python. But here you will not be able to see the result because it runs, prints and closes as soon as it's done. As you can see, it shows up for just a fraction of a second. If you are using Visual Studio Code, you can search for an extension called Python and install it. I have it already installed. Now you can create a file with the extension .py inside Visual Code, and when you click on this little play icon, it should run it in the terminal. If you are using Linux, then chances are Python is already installed in your operating system, because quite a lot of tools in the Linux ecosystem depends on Python. You can confirm this by opening up a terminal and writing Python 3. So if you get this thing, it means it's installed, and if you see something like command not found, then Python is not installed. In that case, the best way you can install it is by searching it in Google for your particular Linux distribution, because different Linux distributions have different way of installing softwares. You can exit it by pressing Ctrl D. Open up a terminal and run the command Python, and it should open up something like this. This is known as the interactive interpreter or the read eval print loop. So basically it reads your input, evaluates it then and there, prints the output and continues. So here you can write usual Python code and it should show the output as soon as you are done. This is a more like an interactive way of, so if you want to see what your code is doing line by line, you can use this. This is also good for learning and debugging, but for running a script, generally this is not ideal way. So we'll see how to run a script non-interactively. So you can exit it by pressing Ctrl D. To run a script non-interactively, you can create a file with the extension .py and write a Python code inside here. Save it and then write the command Python, but this time follow it up with the name of the file or the path of the file. And when you press enter, it should run and print the output. And just like in Windows, if you are using Visual Studio Code on Linux, you can also create a file with an extension .py and write your usual Python code. And if you have the Python extension installed, which you can go to the marketplace and search for Python, and install it. I have it already installed. Then with the file open, you can click on this run code icon and it will run your code. So from now on, we'll use this approach, writing the code in Visual Code and running it with this run icon. But sometimes I will go back to the interpreter to see how different kinds of codes looks like in the interpreter. So let's start by printing things. Now, printing does not mean that we are going to print something on your printer, but printing in the context of programming means showing some output on your screen. So the way we do it in Python is by using the print statement or the print function. So we write print followed by a parenthesis, and inside double quotes you can write whatever you want. So let's write hello world. And when you run on it, it should output the whatever you wrote inside this print. You can use multiple print statements in one program. And they should print one after another. And as you can see, print automatically makes a new line after one printing. So when it printed hello world, it automatically went to the next line for the next print statement. You can print numbers too. So if I write print 12, it should print 12. And as you can see, I did not put quotes in here. So when you are trying to print numbers, you should not put quotes. And even if you put quotes, the output will not be different. As you can see here. However, thus putting 12 inside quotes and without quotes have quite a little bit of difference in terms of programming or in the context of programming, but we'll see that later. Now let's start doing some operations. In Python, you can do your usual arithmetic operations with numbers. So for example, I can add two numbers. Here I can subtract two numbers. I can multiply two numbers. So the syntax for multiplying is by an asterisk sign, as is the norm in almost all programming languages. And I can also divide. So as you can see, if you divide two integers, the result becomes a decimal point if they are not divisible by one another, of course. So there is another operation known as the quotient, which gives you the quotient of the division. So if I divide 4 by 3 and if I divide 4/3, so the difference is that 4/3 will give you the fractional result, if the result is a fraction, of course, whereas 4/3 will give you the quotient. So if you divide 4 by 3, the quotient is 1 and the remainder is 1. So this will give you the quotient. You can also give the remainder by using the percentage sign. As you can see here. So the remainder is 1. So in the terms of Python, these decimal point numbers are known as floats, whereas these numbers are known as integers. So float stands for floating point number. Now you can work with floating point numbers directly by just using them in place of integers. So let's say I add 1.2 and 2.3. So the result will be a floating point number once again. So whatever operation we did on integers will also work on floats, and you can also operate between an integer and a float. The result will again be a float, as you can see here. The next operation is exponentiation, or raising to the power, as we say generally. So if I do this, it should give me 2 cubed. So the double asterisk stands for exponentiation. As you can see, it produces 8. And you can also use fractions in exponentiation. So for example, 2 raised to the power of 1 over 2. As you know from your maths knowledge, it should give me the square root of 2, and it actually does. And just to reiterate my point, every numerical operator can also be used with floats. Addition, division, subtraction, multiplication, division, remainder, and exponentiation, all of them work with floats also. So one thing you might have noticed, the subtraction of 2.3 from 1 produced some weird thing. So as you know, it should have produced minus 1.3, but instead it produced something like this, which is very much close to 3 but not exactly 3. The reason we will learn a little bit later, because this is something that occurs in every single programming language out there. So strings are a bunch of text put inside single quotes or double quotes. For example, this. So here I have put hello inside 2 double quotes. This stands for a string. I could have also put it inside 2 single quotes, and it would not have made any difference whatsoever. If I run them, I get the same output for both of them. So anything you write as a string or inside these quotation marks will be shown as it is, almost. But there are some cases where the things change, especially with the backslash character. So let us see that. So let's say I have a string that starts with a double quotation mark, and inside that I want to write a double quote. As you can see, this gives an error. The reason is that whenever the Python interpreter sees this quotation mark, it thinks that this stands for the closing partner of this guy, and it thinks, okay, I am closing the string. And when it sees the rest of the string, it has no idea what to do with it, because the string has already been closed. So if you want to write double quotation marks inside a string that uses double quotation mark, you have to use backslash. So we call this escaping the quotation mark. It means when the interpreter sees this quotation mark, it does not think that this closes the string. It just treats it as some another character. You will see the output. You can, however, use single quotation marks inside a string that uses double quotation marks, and vice versa. So you have to just remember, if you enclose the string within double quotation marks, you cannot use double quotation marks inside it without escaping it. And if you enclose it within single quotation marks, you cannot use single quotation marks without escaping it. The backslash also does a little bit more. So there are some special characters that you want to use inside your strings but can cause problems. So one of the best examples is having a new line inside your string. As you can see, if you put a new line inside your string, this gives you an error, because the string should finish within one line. The way to fix this is use \n. So the \n is a special character known as an escape character, which stands for new line. You can see it entered a new line. There are other escape characters, for example /t for tab, which produces a larger gap. Now there is a problem if you want to print / itself. So if I write something like this, this is a \. As you can see, I get an error because the \, when the interpreter sees this \, it thinks that it is going to see some escape strings, but unfortunately it is not. So the way I can print / is by using double \. And if you forget to properly terminate your string, so for example I write this is a wrong string and I forgot the ending semicolon, then I will get an error when I try to run it, which will be something like this. So UL while scanning string literal. So UL stands for end of line. What this basically says is that it was looking for the closing double quote, but it instead the line ended. So make sure you do not do this. So Python has another style of creating strings, for example like this. So I can use 3 double quotes, make sure to close them. So this string can contain new lines and it will not give you an error. Just like numbers, you can do operations on strings too. The most used operation is probably the addition of strings. So for example, if I have 2 strings and I use plus, so they will be concatenated, they will be put after each other. I don't know if that made sense or not. So like this, so the second string is combined with the first string and printed. So here does not matter whether your strings are enclosed within double exclamation marks or single exclamation marks or triple exclamation mark. So for example, you can have one string that is enclosed within single exclamation mark or single quotation mark and another with double, and it will still work. Also, as you can see, if you want there to be space between these 2 strings, you have to put the space manually. So the 2 strings will be combined one after another without any gap. Just remember that. However, you cannot add strings to numbers. This will give you an error. So not everything is JavaScript, right? Some of them have logic. So if you want to add to a string anything other than a string, you will get an error. You can only add 2 strings. You cannot subtract strings. Or multiply strings. However, you can multiply a string by a number. As you can see, I multiplied the string hello with 2 and I got the same string repeated twice. So no matter what you write here, it will repeat it that many times. So here you can see hello repeated 10 times. The same works if you put the number before the string. However, you have to remember that this number should be an integer and not a float. If you put a float, even if that float is a whole number, you will get an error. Like this. Also, you can't divide a string by another string. I mean, that doesn't even make any sense, right? So a variable allows you to store a value by assigning it to a name, which you can use in your program to refer to the value. For example, let's say I want to store the name James in a variable. So first I will think a name of the variable. So let's say I name the variable user, and then I will write equals followed by the value. So this tells the interpreter that, okay, create a variable named user, put the value, put the string James inside it. So next time I can use the variable to refer to the value. So if I do print user, so when the interpreter sees the value, sees the variable name user here, it will look up the variable called user, find its value, and put it in place of the variable name. So if I run it, it should print James. Now the quotes in here is absolutely necessary because this determines the type of the variable. So if you forgot to use quotes, what will happen is that it says name James is not defined. In other words, it means that the Python thinks this is a variable name because it does not have a quote. So you have to remember, if you want to put a string as a value of a variable, you must surround it with quotes. Does not matter what kind of quotes you use. However, if you want to store a number, you do not need to use quotes. I mean, you can use quotes, but that would make it a string. Now if I hover over it, you will see that it says core is int. So what this means is that Python knows the type of this thing. It knows that it is an int, so it automatically reduces that this is an int. If I put quotes here, then it says that it's string or str. Now even though they might look the same, so let me print the score. You'll see it prints 1, and if I did not use the quotes, it would still print 1. However, the difference is that all the variables have a type. So when I write like this without quotes, it means the type of the score variable is int, and when I write it with quotes, the type of the score variable becomes string. Although they look the same, but there will be a little bit of difference, which we will see later during the operations. Now you cannot use any name you want for the variables. So there are some restrictions on what you can use in your variable. So you can only use letters, numbers and underscores inside your variable name, and the variable name should not begin with numbers. So for example, this is a valid variable name. This is also a valid variable name. However, if I start the variable name with number, I will get an error. As you can see, it says invalid syntax. And also if I try to write something else in my variable name, for example hyphens or slashes, I will give an error. I will get an error. Yes, as you can see, it gives me an error. Also, you have to remember Python is a case sensitive language, which means that if you change the case of the variable names, it will be different variable. So for example, this thing and this thing, they are different because as you can see here, the first letter is capital and here the first letter is small. So these two are different entities in terms of Python. So you have to be a little bit careful. If you have a variable and you want to use it, you must keep in mind the case of the variable. Now you can do operations with variables. So whatever we did with numbers and string, etc., the same can be performed with variables. So for example, if I have a variable called score and I have a variable called score2, let's say, so I can do all the operations I saw. I can add them, I can subtract them, I can multiply them, and divide them. You get the idea. So the values of the variables will be substituted in place of them and the operation will be carried out. So as you can see, score has a value 1 and then score 2 has a value 10, so their sum becomes 11. Now you can operate between a variable and a number also. For example, like this. So here I am adding a number with a variable and this should produce the same or the usual result. However, you have to keep in mind the type of the variable as I was saying before. So if you add two variables who have different types which cannot be added, you will get an error. For example, let me create a variable. For example, let's say if you have a variable named user which is a string and you want to add that with a variable of the type int, you will get an error. Because you cannot add a number to a string, so you cannot add a number variable to a string variable. So this is where your type matters. Now you can assign a value to a variable as many times as you want throughout the program, and you can even change the type of the variable. So here my score 2, let's say, is an int. However, if I assign something different to it, for example, I reassign a string, so you will not get any error. Now the score 2's type changes to string. Now I can print it and it will work as usual. So this means that Python is a dynamically typed language. In other words, the type of the variable can be changed on the fly. However, it is not a good idea to change the type of the variable. I mean, it's a good idea to stick to one type. Now that we know how to use variables, let us see how we can take input from the user. So to take the input from the user, we use the function called input. Now when I run this code, this will stop the execution of the program and will wait for the user to enter something and press enter. So I can actually store the result or whatever the user entered in a variable. So let's call it x. So let us print x. Now in order to run this code, this play button will not work because you cannot enter anything in the output that VS Code shows. So for that we need to run it in the terminal. So I will open a terminal by pressing Ctrl plus backtick and then I'll write Python followed by the name of the file. And as you can see, it stops here because it encountered the line containing input and now it waits until I write something. And when I press enter, as you can see, it prints it. So when I write hi and press enter, the result, the hi, is stored inside the variable x, and then I can use it anywhere I want. So for example, I can print something like the user entered. Now here you see I use the plus operator to concatenate two strings. We have already seen how string concatenation works. Now if I run it and enter something, I'll get it back. Now you have to remember the result of the input variable is always string. So for example, even if I entered a number, it will be converted to a string. So you cannot do something like y equals x plus 1, because even if I enter a number, it will be converted to a string and I will get an error. To fix this, if you want to make it a number or anything else, you can convert it by doing this. So if I do this int x, then it converts the variable x into an int, and now my code will work. As you can see, there is no error. I mean, it didn't show anything because there is no print statement. But you have to remember that you have to, in this case, you have to enter a number, otherwise you will get an error. Because if you try to convert something that is not a number, you will get an error. So you can also put something in the parentheses of the input function. So for example, if I write this, not int, but input. So now if I run it, you'll see it shows me this prompt. So whatever I write inside this int parenthesis or the input parenthesis, it will be shown as a prompt. So it is a kind of like a good thing to let your user know what they're about to enter in a program. So for that you can use this. Now before we end this part with the variables and inputs etc., let us see some other operators. So these are known as the in-place operators. So in-place operators are basically just a shorthand or the shortcut for writing some of the more big operators. So for now let's take an example. So let's say I have a variable called 2 and I write this. Now this might look weird. I mean, if you are not familiar with the context of programming, I mean, if you look at this thing simply from a mathematics perspective, this might seem weird. X is equal to x plus 2. But you have to remember this equal is not an equality operator that we know. This is the assignment operator. So what it does, it takes the value that is in the right hand side and puts it in the variable in the left hand side. Just like this. So it takes the value 2 and puts it in the variable x. Similarly this thing. So it takes the value x plus 2 and puts it in the variable x. So this will take the original value of x, add 2 to it, and then store it back in x. So if I now print it, x should now be equal to 4, as you can see here. So similarly you have other operators like x equals x minus 2 and etc. So all of these operators where you take one variable and add, subtract, multiply, divide something by it and then store the result back in the same variable. So all of this can be replaced by a in-place operator. So the syntax for this, it looks like this. So x plus equals 2. So this is the same as x equals x plus 2. So it means you take the value of x, add 2 to it and then put it back in x. Similarly you have x minus equals 2, you have x product equals 2. So all of them follow the same formula. Whenever you see something like this, an operator followed by equals to, it means that you are doing the operation on the original value of the variable and the result is stored back in the same variable. So this means you add 2 to x and store it back in x. This means you might subtract 2 from x and then store it back in x. Similarly you multiply x with 2 and then store it back in x. So you take the remainder of x and 2 and then store it back in x and so on. So this can also be used on strings as well. So for example like this. So you have one string called hello and then you add world to it and then store it back in the same variable. Alright, now we are going to do some control structures. But before that we need to look at another type of variable which is very common. So these are called Booleans. So Boolean variables are either true or false. So basically they can only be in any one of these two states. So these are very much useful if you want to check some conditions, compare some variables and other things. So let's see. So I can use them as usual variables. So Python has two Boolean values. We have a true and we have a false. Now be careful that the T and the F are capitalized. This is something that is different from quite a lot of other languages because usually they are all lowercase. But if you write them lowercase, you will get an error. So these two are special Boolean values. So these two are the only possible Boolean values. So any Boolean variable is either true or false. Now in the context of Boolean variables, Python has some comparison operators. So let us look at them. So each of the operators will take two values and compare them, and the result will be either true or false. So let us see. So the first operator is the comparison operator, and this is two double equals. This is two equal sign. I mean, my font is rendering it as one long equals, but this is actually two equal sign. So what this does, this compares 2 and 3, and if they are equal, they print true, or the result of this operation is true, and if they are not equal, the result of this operation is false. And you can probably guess that the result of this is false. So I can also store the value in a variable, and I can work with that variable as usual. So as you can see, I stored the result of this comparison in the variable x, and then I printed x. Now here is one quick note: you should not confuse between the single equal sign and the double equal sign, because the single equal sign stands for the assignment operator, which means you are putting a value in the variable, but the double equal sign stands for comparison. And I mean, in C and C++, if you interchange these two operators, the programs would probably run correctly. The programs would probably compile and will not give you an error, but the logic will be different. But Python, it is pretty rare to confuse these two and get away without any error. I mean, if you did something else, there would probably be an error. So other relational operators are there, as you might guess. So there is less than, so there is less than equals. Let me just quickly turn the ligature off because it might confuse people. Yeah, so we have less than, we have less than equals, we have greater than, we have greater than equals, and these all work the same way as you would expect. So 2 less than 3 is true, 4 less than equals 5 is true, 4 greater than 5 is false, and 8 greater than equals 9 is false. Now you can also chain two of this. So for example, you can write 2 less than 3 less than 5. So in languages like C, C++ or Java, this will not give you the correct answer, as you might guess, but in Python it will. As you can see, it gives true. So in case you are not familiar with the difference between less than and less than equal to, so less than equal to is just the same as less than, except if you have two equal numbers there, it will return true. So less than equals means it's either less or equal. So that's why 5 less than equals 5 is true. Now you can also compare integers and floats. So 2 less than 2.5 should return true. However, you cannot compare to a number and a string. So 2 less than string 2 will give you an error. You can, however, compare two strings. So for example, like this, hello and hi. So this is true. So the way string comparison works is famously known as the dictionary order. So basically, A less than B will be true if A occurs before B in a dictionary, and it will be false if A occurs after B in a dictionary. So here hello occurs before hi in a dictionary, because although the first characters are same, the next character, the second character E, comes before I, which means hello will come before hi in a dictionary. So that's why the result is true. So two strings are equal if all of their characters are equal. I mean, this is probably understood. And finally, there is another relational operator, which is the not equals. So this is basically the opposite of equals. So that is a exclamation mark followed by an equal. So this you should read as not equals. So it means it will be true if these two numbers are different, and it will be false if these two numbers are equal. So this is basically the opposite of the equal sign. Now let us look at a few logical operators. So the logical operators are basically operators that operate on booleans. However, I am saying booleans although they can operate on other things, but there is a catch that I will talk about later. For now, just remember that these operators work on booleans. So let us take a look at the first operator. So the first operator is and it works like this. So the operator is and it is usually spelled as in English, and it takes two booleans, so either true or false, and the result will be depending on, and the result of the AND operation will be true if both of these inputs are true, and if any one of them is false, the result will be false. So as you can see here I have true, and the result is true. However, if I have false on either on the right side or on the left side or on both sides, the result is always false. So this is probably quite clear from the intuition. I mean, if I say something with an AND, I probably mean that both of my conditions should be true. The next operator is OR and works kind of like similarly. So this also takes two booleans as inputs, and its result is something like this. So if any one of the operands is true, the result will be true, and the result will be false if and only if both of them are false. So here, as you can see, I have true on both sides. Here I have true on the left side, and here I have true on the right side, but the result is always true because at least one of them is true. However, here I have false on both sides, and only in that case the result is false. And this is also clear from intuition. I mean, if I say A or B, I probably mean that any one of them should work. So if any one of them is true, the result should be true. The next operator is XOR or exclusive OR, and the sign of the operator is caret. So unfortunately this is not spelled in English but used as caret. So this is the same as OR except only in one case. So as you can see from the output, so this is the output of the OR, usual OR, and this is the output of the exclusive OR. So as you can see, only the first one is different. So you have to remember that. So when I say just OR, I say that it is true if at least one of its inputs is true. And when I am talking about exclusive OR, I say that its output is true if exactly one of its inputs is true. So only these two cases it will be true, because in both of these cases exactly one input is true. However, here both of the inputs are true, so that's why it is false. Here both of the inputs are false, that's why it is also false. So the only difference between OR and exclusive OR is that exclusive OR expects exactly one true in order for it to be true, whereas our usual OR expects at least one input to be true in order for it to be true. And finally we have Boolean NOT. So this takes only one input, and it's very easy, it basically flips it. Oops. So if the input is true, it will become false, and if the input is false, it will become true. As you can see here, so not true is false and not false is true. So instead of using them directly on true and false, we can use them with the result of some kind of comparison. So for example, something like this. So this here I am doing 2 less than 3 or 5 greater than 4. So as you know, 2 less than 3 is true and 5 greater than 4 is false. So the OR, one side of it is true and another side of it is false, so the result will be true, as you can see here. Similarly, I can use all the common logical operators that I showed, something like this, and all of them will work. And also I can have multiple of these. However, now there might be a confusion which one of these two will run first. So will the AND run first or the OR run first? So that is a question that I will answer a little bit later. So this is also same for any other operator. I mean, if you have more than one operators in one line, which one of them will run first? So that's a question I'll answer a little bit later. Now let us look at a control structure. So first control structure that we will learn is the if statement. So the if statement checks the condition, and based on the result, so either if it is true or false, depending on the result, it will execute some code. So the syntax of if looks like this. So you have if followed by a space, and then you write your condition here, followed by a colon, and the next line. So next line you will have to press tab, as you can see here. So if you are using Visual Studio Code, it will automatically press tab for you, and here you will write all you want, and when you are done, you have to come out of the if statement by removing the tab. So let's take an example. So if I write if 2 less than 3, print yes. So this is my condition, and this is the statements inside the if block. So this entire thing is an if block. As you can see here in VS Code, you can easily fold them. So now, as you can see here, we have a tab, so that Python actually depends on indentation, as we call it, to separate blocks. So if the tab was not there, you would get an error. We'll see that. So what it does is that, so if 2 less than 3 is false, so if 2 less than 3 is true, it will execute whatever is inside here, inside this if block. And if this condition is false, it will skip this part and will go to the end. So let us run. As you know, 2 less than 3 is true, so it will print it. Now if the tab was not here, you would get an error. As you can see, you will get an indentation error. So let's take a look at this. So what does this do? So as you can see, if 2 less than 3 is true, it will print this thing, and when it is done printing, it will go to this line, and then it will execute it. So first it executes whatever is inside the if block because the condition is true, and then it comes out of the if block and continues normally. So it prints this. However, if the condition was false, then as you can see, this entire if block is skipped. So 2 greater than 3 is false, so this whole thing is skipped, and the program jumps to this statement. So whatever is just below the if statement will be executed. So you can have multiple if statements, one inside another. So for example, I'll take a look at this. So let's say I have a variable called num, whose value is, let's say, I take from the user. Now you want to compare it to a number, so I have to convert it. So I can convert it here. So if you are confused by this syntax, so for now just imagine that this is converting the user input to integers. So we'll learn about this syntax later in functions. So user will input something, and I am storing it in the num variable. So I write something like this. So here I have 3 if conditions. So the first if condition asks, is the number greater than 10? So if the number is greater than 10, this entire block will run. As you can see, this block is inside the if statement. So it will first print bigger than 10, and then we have another if condition. So is the number greater than 15? So if the number is greater than 15, this entire thing will run. So it will first print bigger than 15, and then it will compare if the number is less than 20 or not. So if it's less than 20, it will print less than 20. So let's try that. So it's waiting for something. So let me enter 12, and it prints bigger than 10. Now you might wonder that 12 is less than 20, so why it did not print it. So the answer is that, as you can see, this statement is a part of this if statement. So the only way the program will reach this part is if it enters this if statement. So is the number bigger than 15? 12 is not bigger than 15, so this entire thing is skipped, whatever is inside this if, this second if, this part. So that's why even though this condition is true, this is not executed, because the program never reaches this part. And if I enter something, for example 22, as you can see, it prints bigger than 10, so of course it is bigger than 10, so it prints this. Then the second condition is also true, so it also prints this, but the third condition is false, so it does not print this. You get the idea, right? Now, as I said before, the indentation is necessary. So if, for example, if it were not indented, what this would do, so if I write 12, as you can see, this time it prints less than 20. So this time this if statement is part of this one. So 12 is greater than 10, it's true, so it prints bigger than 10. Then it checks this condition, which is false, so it skips this part, and then it comes to this. You see, because this if condition is part of this one. This time the third if is not part of the second if, so there is no way so the program will not skip it. So it will compare this, so the number is less than 20, and it prints it. So as you can see, just by changing the indentation, I can change the flow of the program. So you have to keep this in mind when you are writing if conditions. So one mismatch indentation and your program will change forever. So as you saw, the if statement will allow you to run some statements if the condition is true, and if the condition is false, it will skip to the end of the statement. So here is once again another example. So here, so if this condition is true, it will print yes, and then go to this line, because it will continue normally after the if statement is over. So no will also be printed, and if this condition is false, then it will directly skip to it. So once again no will be printed. So no matter the condition is true or false, no will always be printed. But sometimes you might want to do something like, so if the condition is true, do this, if the condition is false, do something else. So this is not the way for that, because as you can see, this something else will be executed regardless of whether this condition is true or false. So for that, Python has an else statement. So we write it like this: else followed by a colon and then some statement. Now when I run it, so if the condition is true, it will execute this if, and since this if has a partner else, it will not execute the else part, it will jump to here. So let me write another thing. So now if I run it, as you can see, this condition is true, so it prints yes. Now it skips the else because the if part is true, and jumps directly to the end. And if the condition is false, then it will skip the if and go to the else, and once it continues with the else part, it will come to the end. So think of them like partners. So only one of them will be executed for one condition, for one particular condition. So if the if part is executed, the else part will be skipped, and whatever is after the else will be executed. And if the condition is false, the else part will be executed, and then whatever is after the else. Now two things to notice is that this else should always be after an if. So if you do not have an if you just have a direct else, you will get an error. As you can see, it will tell you it's an error. Second is that this else should be on the same level as if. So if you by mistake put it inside the if, you will get an error. And whatever is inside the else should also be indented, just like the if statement. So if you do not have the indentation here, you will again get an error. So these three things you have to keep in mind. Now another thing you have to remember is that, so for every if, it can have either no else block or exactly one else block. If you put more than 2 else block, you will get an error. So for example, if I do this will also be an error, because for one if there can be only one else. Now inside else you can also have if statements. So for example, like this. So here I have a big quote. So first I put the value 3 in a number, then I compare. So is number equal to 1? If it is 1, print 1. Else, now inside else I have another big bunch of if. So if the number is 2, I print 2. Else, if the number is 3, I print 3. Else I print something else. So the output, what will be the output? So the output is 3. So the way it works is that, so is the number equal to 1? This condition is false, so we go to the else part. Now inside the else there is another if. So is this condition true? Is num equal to 2? The answer is no, it's false. So we go to this else. So this else is the partner of this if. So the way to remember is that whoever these two will be on the same indentation level. So this else is on the same indentation level as this if. So these two are partners. So if this is false, we come to this. Now then we compare this. So is num equal to 3? The answer is yes. So we print 3. So if you do something like 5, then it would print something else. So this is false, go to this else. This is false, go to this else. This is also false, go to this else and print this. Now this looks ugly and difficult to maintain. I mean, if inside else. So for that we have another syntax known as the elif statement. So elif stands for else if. So let us write the code like this. So here you will notice I have used something called elif. So elif stands for else if. So what this does, this entire if, elif and else is one big family. So as you can see, all of them are at the same level. So all of these are family. So the way it works is that the first condition will be checked. So if it false, the second condition will be checked. If it is false, the third condition will be checked. And finally, if all of them are false, the else will be executed. So let us try that. As you can see, it prints 3. So is num equal to 1? The answer is no. So we come to the next elif. Is this true? No. So we come to the third elif or the second elif. Is this true? Yes. Then print it. Now here you can see in one family, exactly one of them will be executed, just like a normal if else. So if this one is executed, all the other ones will be skipped. If this one is executed, all the other ones will be skipped. So here this one was executed, so other ones were skipped. The else were also skipped. So if I changed it to like, let's say 78, so it prints something else. So this condition is false, go to this. This is also false, check this one. This is also false, go to this. So as you can see, this else does not have any condition. So if none of them are true, this will be executed. Now the else is actually not mandatory. I mean, if you do not have this, you will not get any error. But except that if none of the conditions match, you will not see anything. So this is useful if you have quite a bunch of conditions, but you should use it only if you have a lot of conditions, out of which only one will be executed. Only one should be executed. In other words, if you have mutually exclusive conditions, so only one of them will be true at a given time. Now before we go on to do anything else, let us talk about operator precedence and associativity. So what is precedence? Now this is something that you might have learned in your maths class or something. So the precedence is when multiple operators share some operand, The precedence determines which one of the operations will be done first. So consider this statement or this expression, 2 plus 3 minus 4 times 8. So here, as you can see, this plus operation and the subtraction operation shares one operand. Again, this multiplication and this subtraction operations also share an operand. So depending on which one is evaluated first, the results will be different. So for example, if I just evaluate it from left to right, so 2 plus 3 will be 5, then 5 minus 4 will be 1, and 1 times 8 will be 8. But as you can see, the result is minus 27, which means the usual way of reading from left to right and evaluating is not performed here. In fact, the multiplication is performed first. So 4 times 8 is minus 32, and then 2 plus 3 is 5. Finally, 5 minus 32 is minus 27, which you can see here. So in Python, the multiplication operation has a higher precedence than addition and subtraction. So that's why multiplication is performed first and then the others. So this is something that you have to remember, and most of it is easy because it follows the usual precedence operator rules in mathematics. But so still, let me just give some examples. So the first operator that has the highest precedence, that is the parenthesis operator. So basically, if you group any part of the expression in parentheses, that part will be evaluated first. So for example, something like this. So now I have just the same expression, except I have covered this thing in a parenthesis, and now as you can see, the result is minus 6 because this is evaluated first. So this becomes minus 1. Then the default order is multiplication first, so minus 1 times 8 becomes 8, and then minus 8, and then minus 8 plus 2 becomes minus 6. So using parentheses, you can change the default order of evaluation. Anything that is inside a parenthesis will be evaluated first. So after parentheses, we have the exponent operator, which has the second highest precedence. Then we have bitwise not, which I have not shown yet. So we'll see what it does in a later bit. Then we have multiplication, division, modulo, and quotient. So these 4 operations all have the same precedence. After that, we have addition and subtraction. Then we have bitwise shifts, so bitwise right shift and bitwise left shift. So this is also something we have not done yet, so let us not think about it too much. Then we have bitwise AND, bitwise XOR, and bitwise OR. Again, bitwise things I have not shown yet, so let us put them aside for now. So after that, we have all the comparison operators. So equals, we have not equals, we have greater than, less than, greater than equals, and less than equals. Then after that, we have the assignment guys, so the usual assignment operator. Then the short in place operators, so these ones. All the in place operators. After that, we have 2 more things that we have not done yet. So one is and the second one is not. So let me just put a comma between. So this is something we have not done yet, and the second one, which is in and not in, this is also something we have not done yet. But the last one which we have done, which is and, or, and not, these 3 we have done. So the logical operators have the least precedence, and parenthesis has the highest precedence. So this is something you have to remember. I mean, it is mostly familiar, especially these stuffs. These are our usual mathematics precedence. Now here's another thing, as you might have noticed that plus and minus have the same precedence. So what happens when there is a clash between them? For example, here. So here, will this plus be evaluated first or the minus will be evaluated first? I mean, both of them have the same precedence. So in this case, we look at a second thing which is known as the associativity. So the associativity is either left to right or right to left. So left to right associativity means the things will be grouped from the left side. So let me show you by an example. So for example, this thing 2 plus 3 minus 4. Now plus and minus both have left to right associativity, which means that you start reading the expression from left to right, and whenever you see an operator, just group them. So when I go from left to right, the first operator that I encounter is plus. So basically this will be grouped like this, and after that the minus 4 will be. So the easy way to remember it is that, so if you have two operators with the same precedence that share one common operand, so if the operators are left to right, you just group it towards left. So since plus has associativity left to right, the middleman, the operator or the operand 3 will be grouped towards the left. So mostly all the operators are left to right associativity except two. So one of them is exponent and another group is the assignment group. So for example, these guys, equals, plus equals, minus equals, and so on. So these operators are the only ones which have a right to left associativity. And just for an example, let me show in case of exponentiation what I mean. So if I write something like print this 2 to the power 3 to the power 4, so what does this do? Is this equal to this? So will the operators be grouped towards left, or will the operators be grouped towards right? So if I run it, the output, as you can see, matches with this one. Since exponentiation has a right to left associativity, it means that it has a tendency to go towards right. So this one on the right will be evaluated first and then this. So this is basically equivalent to saying you first compute 3 to the power 4, which is 81, and then evaluate 2 to the power 81. Whereas this one will be 2 to the power 3 first, which is 8, and then 8 to the power 4, which will be 4096. So only the exponentiation and the assignment family has a right to left associativity. Now that we know precedence and associativity, we can expand our knowledge on if a little bit more. So far we have done only one condition in if, but here we can actually chain multiple conditions with if using the and or operations. So let's take an example. So let's say I have a variable called marks which stores the marks of some student, and now I want to do some checks. So if marks is greater than 90 and less than equal to 100, it is a grade A. If it is greater than 70 and less than 90, then it is grade B, and so on. So let us see. So I can write something like this. So now that I write this, here I have 1, 2 and 3 operators. Now I just showed that AND has the least precedence. So which means that this is basically saying this will be evaluated first, this will be evaluated, and after that the AND will be done. Otherwise it would be something like this, which doesn't actually make sense. So 90 and marks, so this comparison will not make sense. So this is why and or have the least precedence. So now I can write like this. So the grade is A, and then we can do other things. So else if marks is greater than 70 and marks is less than equals 80 or 90, so we print B, and otherwise we print C. And if I run it, I will get the expected output. So 80 is in between 70 and 90, so I get B. So in this way I can add multiple conditions in if. I could have also added or and more than one also, so something with and then an or. For example, like this. So let's say I have two variables. I write something like this. So here I have three conditions. So one of them is changed with AND, another one is changed with OR. So can you guess if this condition will be true or not? So let us go step by step. So first of all, as we know that AND and OR has the least precedence, so which means first these will be grouped together, these will be grouped together, and then this will be grouped together, and then they will be evaluated. So x equals to 2 is false. So this is basically false. So y equals 4 is true. And x plus y less than equals to 7 is also true, because 1 plus 4 is 5, which is less than 7. This is also true. Now we have only two operators who both have the same precedence, so this time associativity will come in. Since AND has left to right associativity and OR also, so which means these from left to right they will be grouped. So this will be grouped like this. So false and true is actually false, because in AND if both the sides are true then only it is true. So this is false. Now it's only the case of OR. So false or true, at least one side is true, so the result will be true. And let us actually check that. So as you can see, it prints yes, which means this condition is true. So far whatever code we have written followed a top-down approach. So what it means is started from the top and continued to the bottom. But now we want to learn another control structure which is known as the loop. So what loop does, it basically repeats a part of the program following some conditions. So let's take an example. So suppose I have to write a code that can print numbers from 1 to 5. So I can do this. So this is a code that prints from numbers from 1 to 5. I mean just 5 print statements. But this is not very useful approach. I mean writing numbers individually one after another is not a good approach. So if someone tells me to print numbers from 1 to 100, I have to write print statements for 100 times. And that is not something we like to do. So here we use loop. So there are two types of loops, the while loop and the for loop. So for loop we will do a little bit later when we learn lists. So first we will learn while loop. So the syntax of while loop looks like this. So you have while, then you have a condition, and after that you have some statements. So it kind of looks like if. Oops. So it almost looks the same as if, except instead of if you write while. But the difference is that while loop will repeat this part, this block, as long as this condition is true. So let's write an example. So here I have written a very simple while loop. So I have a variable with a value 1 and this loop. So while I is less than equal to 10, print I. So what this does, so as long as I is less than equal to 10, this part will be repeated. Also let me add this thing. So how will this work? So when the program encounters this line, it first checks the condition. So I is less than equal to 10, is this true? So 1 is less than equal to 10, it is true. So it executes this. So it prints 1 and then increases I. So I now becomes 2. Then it checks again, 2 less than equal to 10 is true. So it prints 2. Increase I becomes 3. Then it comes back to here and checks again. Now this thing continues as long as I is equal to 10. So when I is 9, after this line I will become 10. So 10 less than equal to 10 is still true, but after it prints 10, it will increase I and I will become 11. Now 11 less than 10 is false. So this time this loop will stop and then it will come back to whatever is after the loop. So let's run it, and as you can see, it prints 1 to 10. And after the loop is done, it prints the value of I, which is 11. Since I is now 11, this condition becomes false and the loop breaks. So just for a term, every time this loop runs, we call it an iteration. So when the loop runs for the first time, it is the first iteration. When it runs from the second time, it is the second iteration. So this word will be using very often, so you have to remember it. So I hope this part makes sense. Now you might ask, what happens if this condition is never false? So then your program will also never stop. So let us remove this part and run. So as you can see, it keeps printing and printing and printing and printing. So this has now become an infinite loop. So this stopping condition, you have to be careful about this. So if this stopping condition is never false, the loop will run indefinitely, which is known as the infinite loop. So inside while loops, you can write anything you want. You can also write if statements inside while loop, or another while loop inside the while loop. So let's recap. So while loop has a condition. So if the condition is true, it executes whatever is inside the loop and checks for the condition once more. So as long as the condition is true, it will keep executing the loop, and when the condition is false, it jumps to the end of the loop. Now here's the thing, sometimes you might need to modify this behavior. So for example, you might need to stop the loop early, or you might need to skip some iterations. So for that we have two statements, one is the break and another is continue. So let us see them in action. So first we will do break. So the break statements, when used inside a loop, will cause the loop to stop early. So here I have the usual loop, and after that we have added this. So if I is equal to 5, break. So what this will do, as soon as I becomes 5, it will encounter the break statement and the loop will stop. So the iterations after 5 will not be run. So if I run this, as you can see, it only prints up to 5. In fact, actually up to 4. So let me remove this I, or let me put it here, loop ended. Alright. So as you can see, it only prints up to 1, 2, 3, 4. So when I is 1, it prints 1, it increases I to 2, 2 is equal to 5 is false, so it does not do anything and goes back to here. 2 less than equal to 10 is true. Repeat the loop, this condition is still false. 3 less than equal to 10 is true. 4 less than equal to 10 is true. It prints 4, increases I to 5. This time 5 equals to 5 is true, so it breaks the loop and comes out. So anything after that will not be run. Now, and the second statement is continue. So let us see if I just replace the break with continue. So what continue does, it stops the iteration. Let me also move it to the front. So what continue does, when continue statement is encountered, that iteration, so starting from this point, whatever is after that will be skipped and the loop will jump to its next iteration. Let me move it here. Now let us run it, and you will see it prints something like this: 2, 3, 4, 6, 7, 8, 9, 10, 11. So what this does, so when I is 1, 1 less than equals to 10 is true, so increase I to 2, this is false, so skip this, so it prints 2. So here I have put the increment in the top, I will explain why, otherwise it will be an infinite loop. So it prints 2. For the next one it prints 3, then 4. Now when I is 4, so 4 less than equals to 10 is true, 4 plus 1 is 5, this thing is now true, so the continue statement will be run, and when continue statement is run, whatever is after the continue statement will be skipped. So print 5 is skipped. As you can see, there is no 5 here. So as soon as it encounters the continue statement, it will jump back to the front of the loop and will continue there once again. Now if I had put this here where it was used before, then this time there will be a problem. So when I is equal to 5, 5 less than equal to n is true, then it comes here 5, it encounters the continue and goes back to the loop, but this time I was not increased, so I is still 5, so it comes inside the while loop, it is true again, continue, jumps to the front, comes inside the loop, continue, jumps to the front. So if I is not increased beforehand, as soon as I reaches 5, the increment will not be encountered anymore, so it will be stuck here in this infinite loop. Now also another thing that you have to be careful with this indentations. So if you write break or continue outside a loop, that will be an error. So if you want to run this, it will be a syntax error. So you can only use them inside a loop. So here I have a code. As you can see here, I have one while loop inside another while loop. So let us read this line by line. Also let me just change it to 5 because it will be easier to think. So first I is equal to 1. So 1 less than equal to 5 is true. Now what happens inside this while loop? So I first set j to 1, and then as long as j is less than equal to I keep printing j and increase j. And once j is equal to I, this while loop will stop, and then I print a new line and increase I. So when I is 1, j is also 1 at first. So 1 less than equal to 1 is true. So it will print j, which is equal to 1, and then increase j. So j is now 2, and 2 less than equal to 1 is false. So this loop will stop. So you print a new line and I becomes 2. So when I is 2, then this loop will run twice. So one for j equal to 1 and another for j equal to 2, and so on. So when I print it, it will be something like this. So first 1, then 1 2, then 1 2 3, 1 2 3 4, and finally 1 2 3 4 5. Now here's something that I want to do. So if j is equal to 3, I do a break. Now can you guess or can you answer which one of these loops will the break affect? So will the break stop this loop, or will the break stop this entire loop? So let us run and see. So as you can see, so first we have 1 for I equals to 1. For I equals to 2, it is 1 2. So far j has not reached 3 yet. So when I equals to 3, j should be 1 2 3, but there are only 1 2. Same for the next, and same for the next. So this actually tells us that this break will break this loop, because as you can see, j is not going up to 3. If this break loop broke the entire big while loop, then the loop would have finished sooner. So if you have one loop inside loop, then the break and continue will both affect the loop that is nearest to them. So here the nearest loop to this break is this while loop. So this break will affect this one. Of course this break has to be inside this loop, otherwise nothing will happen. Lists are another data type in Python, just like ints and strings, as we have seen before. So list is a collection of items. So let us see how that works. So let's say I have a list, let's call it marks, where I store the marks of, let's say, 4 students, some random numbers. So this creates a list, as you can see. So in order to create list, we have to use these square brackets, and inside that we write items separated by comma. Now we can also put a comma after the last element, and it is perfectly valid. So you can or cannot put it, it's up to you, but without it, it also works. So this thing is a list. Let us try printing it. Now when I run it, you will see it prints the entire list, as you can see here. Now you can imagine lists as like standing in line for something. So the order of the items in the list matters. So for example, here the first element is 12, second one is 34, third one is 80, and 90 is the fourth one. So each element inside the list has its own place, or what we call an index. So the index does not start from 1, rather it starts from 0. So the index of 12, or the position of 12 inside this list, is 0. Then 1 for 34, 2 for 80, and 3 for 90. So we can access individual elements by using this syntax. So after I write the name of the list, I will put a square bracket and write the number or the index. So marks 0 means the 0th element of the list, which is 12. So if I print it, it should print 12. I can also print 2, which means the third element of the list, because 0, 1, 2, so which should be 80. Now what happens if I try to access the 10th in the 10th index? So as you can see, the list does not have 10 elements. So there I will get an error. Since this list has 4 elements, the valid indices that I can use are from 0 to 3. 0, 1, 2, 3. So anything I want to use after 3 will give me an error, which will read something like this: list index out of range. Now I can also use negative numbers inside the list. So if I use negative numbers, it will start indexing from the last element. So -1 stands for the last element, as you can see here. So -2 stands for the second last element. Then -3 stands for the third last element. Finally -4 stands for the fourth last element, or in this case first. And if I try to go beyond this, I will get another index error. So to remember, if my list has x number of elements, I can use the valid indices are from 0 to x-1 in the positive range, and then -1 to -x in the negative. So the actual valid range is from -x to x-1. So I can also take individual elements out of the list and store them in variables. So for example, mark1 equals marks 2. So I can take the second element or element in the position 2, which is 80, and store them in a variable if I want. Then I can print it and it will print. I can also change the elements in the list by using the same syntax, except this time I will put this one in the left side of the assignment operator, because if you remember, the assignment operator works from right to left. So if I do this instead, this means I change the element which is in the second position to 100. So now if I print the entire list again, you will see that it has been changed. Now sometimes the list might not have any element in it. So in that case you can use which is called the empty list. So let me give an example which you can do like this. So it's just an element, just a list with nothing inside it, which is also perfectly valid. So this is the empty list. Now a list can have as many things as you want inside it, but of course it must be finite. It should stop at some point. But what I want to say is that in a list there can be different elements of different types. So inside the same list you can have a number, have one string, or even another list inside it. So for example, like this. So here this is a list which has one number, one string, and one list inside it. So now if I do L of 0, which means the first element of the list, which is a number. So let me print it. So if I take the L1, it means the second element of the list, which is a string. And if I do this, so L2 means the second element, or the element at the index 0, or the element at the index 2 of the list, which is a list itself. So if I do this, then it means the 0th element of that list, which is 3. So let me print that, as you can see here. So this syntax means, so we first take the element which is at the index 2 inside this list, so it should be a list itself. Then I take the 0th position, then I take the 0th element of that new list. So this is particularly useful if your list has lists or some kind of matrix structure, something like this. So this is a list which contains two lists. you can think of it like a matrix, something like this. So you can think of it like it has 2 rows and each row has 2 columns. So if I print this, so if I do 0 0, so mat 0 means the first list, the first element of that list, which is this list itself. Then the second 0 takes the first element of this list, which is 1. So then if I do so, which means takes the first list inside this mat, which is this, then take the second element, which is this. So it should print 1 2, as you might expect. My bad, I just selected it. There you go. Now one more thing that I want to say is that there are some types that you can use this indexing. So the way we wrote, let me show it again. So this syntax, this using square bracket to take out one element, this is known as indexing. Now lists are the not the only items that can be indexed. We will later see dictionaries and tuples, and maybe someday in some later videos we will see how to create our own types that can be indexed. So but so far the types that we know, out of them strings can be indexed. So when you index strings, you take out the individual characters. So let us see. So let me create a string. So if I do this, t of 0, it means I take out the first character of the string, which should be h, as you can see here. But remember that strings are not lists, so you cannot use a string where lists are expected. For now, just let's assume that they are different. In Python there is something like called duck typing and all other things, but for now assume that strings and lists are different. So strings look like lists, behave like lists by using indexing, but they are different things. They are different beasts altogether. Now let us look at some good things, some list operations. So just as we saw that we can add 2 strings together and also multiply a string by a number, the same can be done with lists also. So let us see. So if I have something like this, let me print it. So I have a list like this and I add it with a list like this, which does the same thing, which just joins these lists together, as was the case in strings. They just concatenated the strings together. The same thing happens here. So the 2 lists are joined together. Similarly, if I have a list, I can multiply it by a number, and as you might guess, this list will be repeated that many times. So like this, 1 2 repeated 8 times. So there are 8, 1 2 3 4 5 6 7 8. So just the same as strings, but again, as you cannot multiply 2 strings, similarly you can't multiply 2 lists also. You will get an error. Now if you remember, when we did the operator precedences, we came across our operator called in, but so far we had not done it. Now we are going to do what the in operator is. So the in operator is used to check if an element is part of a list or not. So let's say if I have a list of marks, now I want to check if someone has got 100 out of 100 or not. So I want to check if 100 is in the string or in the list or not. I will do like this. So the thing that I want to search, followed by in and followed by the name of this list. So this almost reads like English. So I want to print if 100 is in marks or not. So if 100 is in marks, it will return true, and if it's not, it will return false. So since 100 is inside the list, my bad. So if 100 is inside the list, since 100 is inside the list, it shows true. And if I search for something that is not inside lists, I can do false. So you can use this inside if conditions as well. So you can write something like this: if 100 in marks, print someone got 100, something like that, or else, my bad, it should be properly indented, or else print nope, something like this. Since this thing returns a boolean, you can use it in if also any place where a boolean is expected, like while loop and etc. My bad, this one. And what if you want to check if something is not in the list or not? So for that you can use the not operator in conjunction with in operator, and there are actually 4 different ways. I mean, it looks like 4 different ways, but let me show them. So I can do this. So 100 not in marks. So this time I am using an operator not in. So this time not and in, they are not separate operators. This together is one operator. Just like if you have this, maybe show, just like if you have this, and if it's followed by an equal to sign, it becomes a separate operator together. So this time they are not less than followed by an equal to, they are less than equal to operator together. Similarly like this. So this is not the not operator followed by the in operator. This is the not in operator itself. This is one way. I can also do this. This is also true. So this is basically just similar to this. So you are first checking if 100 is in marks or not, and then negating the result. So this is the unary not operator that we saw before, which takes a boolean and then flips it. So this is that. So these are the 2 ways you can check if something is not inside a list or not. So if this item is not inside the list, it will return true, and if it's inside the list, it will return false, as you can see here. Now we are going to look at some list functions. So we do not know what functions are yet, but that can't stop us from doing this. So the list functions are something that modifies the list. So basically we'll see how we can add some items after the list or at the end of the list. We will see how we can get the length of the list. We will see how we can insert some item between the string or between the list, and we will see how we can find elements in the list, and also some other stuffs. So the first thing is, let us get a list, something like this. Maybe not call it marks, maybe just call it nums. So the first function is append, which takes a list and adds some element after the list or at the end of the list. Now you see, if I want to add this letter number 5 after the string, after the list, I cannot do this. So I want to, should be nums. So I want to add the number 5 at the 4th position, right? So 0, 1, 2, 3, and at the 4th position I want to add 5, but this will give me an error because the list's length is only 4. So I cannot use the index 4. So for that I have to use this function. So the way we do it is, we take the list followed by a dot and then use the function append, and inside the bracket I write the element I want to push or append inside this list. So this is kind of similar to the print statement that we have seen before, right? So inside parentheses we pass what we want to put inside. Now if I print nums, you will see that 5 is now inside the list. Now we can also use a function called pop. So what does the pop method do? So the pop method removes the item at the specified position, which, so let's say I want to remove the item that is at the 4th position right now. So let me print nums and see what happens. So as you can see, I removed the element which is at the index 4, which should be the 5 element. Or let me just remove the element at the position 2. So 0, 1, 2, it should remove this 3 element, as you can see here. So the 3 element is gone. Now if I don't pass anything, so if I don't write anything in here, this will by default return or remove the last element of the list. So as you can see, 5 is now removed. Now the good thing about pop is that it actually returns the element that it just removed, so I can store it in some variable and then print it. So as you can see, pop removed the last element 5 and it also returned it, which we stored inside a variable and we can later use it. The next function is the length function. So using it we can get the length of the list. We can know how many elements are there in the list, which is something like this. So let me print it. So len and this. So there is no list. So let me just create a list. Now you might notice we are not writing nums dot len. Instead we are writing len almost like print. Just like print, you write print and then put something in the brackets. Similarly here you write the len function and then put the list's name in the bracket. So this will tell you how many items are there inside the list. So as you can see, there are 4 items in the list. Now this also works with strings. So if you have a string, you can get its length also by the same syntax. So this is one difference that you have to remember, that len, for using len we do not use the dot syntax. Now just like len, there are 2 more functions which do not use the dot syntax, which are max and min. So let us show them also. So the max function takes a list and then, as you can guess, it returns the maximum item in the list. And similarly min takes a list and returns the minimum item in the list. So as you can see, 4 is the maximum item in the list, 1 is the minimum item in the list. Now these all return some value, so you can store these values inside a variable and then use the variable if you want. So here I am just passing that thing inside print so that it prints, but you can store them in variables also. The next function is called the insert function. So let me create a string again. So insert function is almost similar to append, but append puts new element at the end of the list, whereas insert lets you put the element anywhere you want inside the list. So for example, if I do this nums.insert, so first here I will pass 2 values. So the first value is the position where I want to insert the thing. Let us pass 1 and then put 10. So let me print it and let's see what it does. So as you can see, it puts 10, which is the second value that I passed in insert, in position 1. So 0, 1. So in place of 2, it puts 10 and then shifts everything else right side. So everything else shifts right side and 10 comes at the position 2 or position 1, which is the second place. So I could have done it 2 also, which would look something like this. So in place of 3, I will put 10 and then shift 3 to the right. So here I have a list of 3 letters ABC. Let us look at the next function, which is called the index function. So the index function, in case of in operator, we have seen that using in operator we can know if an element is part of a list or not, but we can't know at which position that particular thing occurs. So as we saw before, 100 is in marks, but we do not know who got the 100 marks. So we do not know the position of 100 inside the list. So the index function can hit 2 birds in 1 stone. So it finds out if what you are searching for is in the list or not. So just like in operator, and also it finds out at which position that thing occurs. So let us see that. So let me do this. So letters dot index, oops, what have I written? Letters dot index followed by, let's say A, or let's say B, and then once more letters dot index and P. So in the first case I have written a letter which I know is part of the list, and in the second case I have written a letter which I know is not in the list. So if I run it, you will see that So for B, it actually found out at which position B occurs. So as you can see, B is in the position 1, 0, 1, 2. So B is in the position 1. So this returns 1. And for the second one, so P is not in the list, it raised an error. Now you might think that raising an error is probably bad, but we will see later how we can handle it, how we can handle the later. But for B, it did two jobs. So it found out that B is inside this list and also found out that B is at the position 1. Now the next method is called remove, so which works almost similar to pop, except there is a major difference, which is that, so the first difference is that remove does not return anything. So in pop, when it deleted a value from the list, it actually returned the deleted value. So remove does not do that. And the second thing is that while pop worked with the index or the position of the item, remove works with the item itself. So if I want to remove the second element from the list, I will use pop. But if I want to remove B from the list, I will use remove. So as you can see here now, B is removed. So when I know the position that I want to remove, I will use pop. And when I know the value that I want to remove, I will use remove. So remove removes the value from the list, and if the value occurred twice, it will remove only the first one. So that's something you have to keep in mind. So remove will go through the list and look for this thing for where it occurs for the first time. So as soon as it sees from the first time, it deletes that thing and stops. Whereas pop removes the element at that position. So if I do pop 3, it means I remove the third element. But if I do remove B, I remove B from the list. Now we'll look at another type of loop, which is the for loop. Now I did not do for loop before because in other languages for loop behaves different than Python. So Python's for loop is a little bit different. So that's why we waited until we did list. So the way for loop works is that it operates on a list, and for each item in the list it performs the loop. So let me show you an example. So the syntax of for is that for followed by a variable name, followed by in, and followed by a list, and then colon, and after that we indent the block that I want to execute. So this in is not the in operator that we have seen. So this in is part of the for loop itself. So the way it works is that it takes each element from the list and puts it in the value I one by one and executes the loop. So here I could have used any other variable name. So for this particular case, in the first iteration it will take the value 1, put it in I, and then run the loop. Then for the second one, it will take the value 2, put it in I, and then run the loop. Then for the third iteration, it will take the value 3, put it in I, and run the loop. So as you can see, it prints 1, 2, 3. So first it takes 1, puts it inside I, runs the loop, prints 1. Then it takes the value 2, puts it in I, runs the loop, prints 2. Then it takes 3, puts it in I, prints the value I. And then the loop is finished because there are no more elements left in the list. So here, as I said before, I could have used any variable name, any valid variable name. Something like this. So here I could have used any list. So for example, I would have used this. I could have also used string. We could have also used a list after storing it in a variable, so like this. So I could have created a list before and then put the variable here. So this would have also worked. Now similar to while loops, you can use break and continue inside the for loop, which does the same thing. So just to show, so I can do this and let's say if num is equal to 2, I break. So it will do the same thing. So as soon as number hits 2, the loop stops. And let's say if num equals to 1, we can continue. So let me put it to the top. So if you remember continue, it will jump to the next iteration. So as you can see, it did not print 1 because when num is equal to 1, it continues, which means it skips the rest of the loop and jumps to the next iteration. So here as you can see, there is you do not have to remember to keep increasing the counter variable that we had to do in case of while, otherwise it would turn into infinite loop. So since for works on lists and lists are finite, so you can be sure that this loop will always end. Now there is a way to make this thing an infinite loop using generators, but that is not something we are going to do. So when to use for loops and when to use while loop. So the thing to remember is that we use for loop when I want to loop over items in a list, or in cases where the number of iterations is fixed. So as you saw here, iterating over a list of marks, let's say, iterating over a list of names of students, something like that. Whereas while loop we use when the number of iteration is not known and maybe it depends on something else. So for example, I ask the user how many times do you want to run the loop, and he enters 10. In that case I will use while loop. However, though, these two are actually functionally almost similar and you can use them interchangeably. By using certain tricks, you can transform a for loop into a while loop and a while loop into a for loop, but the for loop is shorter and looks better. So you should use for loop if you can. Now in case of while loop, we saw how we could print numbers from 1 to 10 using while loop. In case of for loops, you see, since for loop works on a list, so if I want to print numbers from 1 to 10, I have to create first the list, which is not good. That kind of defeats the purpose of loops. So for that, I can use something called range. So before we go into the for loop with range, let us see what ranges are. So the range is a function that you call, and pass a value, something like 10. So it returns something, or creates a range of numbers. Before, let's try to print this and let's see what it does, what it prints. So it prints this range 0, 10, and what does it mean? We have no idea. It doesn't make anything clear, right? So the thing to remember is that range returns a sequence. So in this case, it returns a sequence from 0 to 9. Now it might seem weird. So when I pass one value inside the range, it starts from 0 and ends before this number, increments by 1. So if I do range 10, it means 0, 1, 2, 3 up to 9. Now this thing does not return a list. It returns a sequence, which if you print, it will show something like this. And you cannot actually see the values inside it. So if you want to see it, you have to convert it into a list. So you do something like this. So let me print again. So we call the list function and pass it the range to convert it into a list. Now if I try to print it, it will actually print the numbers. So as you can see, from 0 to 9. So range, when I pass it a number x, it creates a sequence from 0 to x minus 1. And when I pass that thing inside a list function, it converts that into a list, which I can print and work with like any normal list. Now if you do not like to start from 0, you can actually pass the starting point in the range, something like this. So if you pass two values, it means you start from 2 and go up to 10, which means before 10. So from 2 to 9, so like this. So 2 to 9. So start value is always included and the end value is always excluded. Now you have pass another argument, which is the step argument. So if I pass 3, So it will create numbers in the gap of 3 like this. So starts from 2, then jumps 3 places to 5, then jumps 3 places to 8, then jumps 3 places, which should be 11, but 11 is bigger than 10, so it does not include that. So step will give you how many numbers to jump by default, which is 1. Now you can also pass a negative number here. So for example, if I pass this, so as you can see here, it creates an empty list. So why is that? So negative number will start from this number and go to this number. So if you use a negative number, you have to, the first starting point should be bigger because you are trying to go backward. So let me put 10 here and then 2 here. So now it will go backward. 10, 7, 4. So you have to remember that this is always the starting point. So if your step number is positive, this should be less than this one. Of course, starting point should be less than the ending point. And if your step number is negative, this should be bigger than this one. So using this, you can create ranges if you want. Now let us see how we can use it for loop. So let's say I want to print numbers from 1 to 10. So I will do this for I in range 10. So here you might wonder that we are not calling the list function. So the list function is actually not necessary if you want to use it for loop. So you only call the list if you want to print the range or index it or take out some elements from the list range. So if you want to use it purely for loop, you do not need to call the list function because for loop can work with range also. So if I now print it, you'll see it prints from 0 to 9. So in this way you can print. So here I am printing number from 0 to 9. If I wanted to print from 1 to 10, I will do like this. So I start from 1 and end at 11, which means 1 to 10 actually, as you can see. Now we are going to talk about functions. So functions are a very important part in any programming language. Now in different programming languages they are given different name, but most of them call it functions. So functions are basically a block of code that you can reuse as many times as you want. Now why should we need this? The reason is that if I have a block of code that I have to repeat quite a lot of times, that first of all that increases the size of the code that you have to maintain, and second is that if you ever have to change something, you have to find the same block that you have used everywhere and change and perform the change in every single places. So if I repeat 4 lines across 100 different places and I have to change one of the lines, I have to go to the 100 different places and change that, which is not good. So for that we use something called functions. Now we have already seen quite a few functions. For example, we have seen the print function, we have seen the len function, we have seen the max function, we have seen the min function, etc. Now these are all functions. The way you can tell their function is by the parentheses. So these kind of statements are called function calls. So this is known as calling the function. So when I write the function name, which is the part before the parenthesis, followed by the parenthesis, this becomes a function call. It means I am calling the function, I am invoking the function here. Now what you see inside the parentheses are called the arguments of the function. Now here the max function takes one argument, which is the list. Similarly the min function, the print function, in this case I have given it one argument, but it can also take more than one. Now let us see how we can actually create our own functions. So in order to create a function, we have to use a syntax. So we start by writing def. So after def, I will give a name to the function. So let us call it my function, followed by a parenthesis. So for now let's keep the parenthesis empty, and followed by a colon, and then after an indentation we will write the body of the function, which will be the block of code that I want to repeat. So for now let me print hello and then print world. And that finishes the function definition. Now in order to use the function, I have to call the function, which is, as I said before, I write the name of the function followed by parenthesis, and when I run it, as you can see, this my function, this call will execute whatever is inside this function. As you can see here, it printed hello world. Now another thing to note is that just like variables, if you call the function before you have actually defined the function, it will give you an error, as you can see. So the same thing happens with variables also. If you try to use a variable before you have actually defined it, you will get an error, the same name error. So in order to call a function, you must have defined it first. Now we'll look at how we can give arguments to the function. So if I have to explain what arguments are, you can think of it like this. So imagine you are the boss of your company and your function are the workers or the employees under you. And when you call the function, it means you are telling that employee to perform his job. Now arguments are kind of like orders. So when I am saying that this function requires one argument, what I mean is that it takes one order from you, the boss of the company, and that order is the argument of the function. So let us see an example. So I want to define a function which takes one argument. So now the arguments are basically just variables, and you can give any name, any valid name that you want. So let me call its argument something like name, and its body will be something like this, hello followed by name. So what this does, it takes its argument and prints hello followed by that argument. So now I can pass something to it, for example this, and run it. So what happens is that this is the order that you are giving your employee. So this value is put inside this variable or this argument, and then this argument is used in the function's body. So these are kind of like boxes. When I call the function, I put the value in the boxes, and then function takes them and uses them. Now I can have more than one argument to it. So let me do something like this. Now if I try to call the function, I will get an error. So as you can see, it says my function is missing one required positional argument. What it means is that my function wants two arguments, but I passed one argument. Now the word positional has a meaning, which we will probably do a little bit later. But in simple words, it means that you are not passing the required number of arguments. So let me pass the second argument. Now if I pass some extra arguments, I will get another error, which tells that it takes two arguments but three were given, which is again an error. Now there are way to make a function take any number of arguments, but we'll do it later. So let us pass the required number of arguments, and when I run it, I'll get the error. So this value goes to the variable called name, or the argument called name. This value goes to the argument called surname, and then they are used in the function. Easy, right? Now so far we have not talked about this, but let me just mention it in passing. So whenever you put indentation inside something, so for example if or while loop or for loop, that creates a new block, and the block means it has the variables inside the block will not be visible outside the block. So for example, if I create a variable inside this function, let's say call it num, then I can use it inside this function as many times as I want. However, I cannot access it outside the function. This will give me an error, as you can see. So whenever you define a new variable inside any kind of block. So it can be the block of if, it can be the block of while loop, it can be the block of for loop, anything. Anytime you declare a variable inside a block, you cannot access it outside the block. Now we have seen this thing. So for example, if I have the len function, so you saw that it takes as argument one list and gives its length. Now you saw that I can actually put it inside a variable and print it, or use it in any case. For example, like this. Now this len function, so as you can see, it gives me back some value, it returns some value. So the same thing we can do with our function also. So from our function we can return a value, and then when I call the function I can store the return value. So this would be something like you give the order to your employee, he performs a job and then gives you a result, like some hike in profit or something like that. So the way we do it is by using the return statement. So return, and then let's say something like I can return any value I want, and when I call this function I can actually store this function to some variable and then use the variable. So as you can see, it prints this. Now you have to remember that the return statement cannot be used outside a function, just like break and continue cannot be used outside a loop. Also, whenever the function encounters a return statement, the function stops. So anything after the return will not be performed. So for example, if I print something after the return, this part will never be printed, as you can see here, because as soon as the function encounters this return statement, it stops. So it also says unreachable code. So just to drive the point clear, let us write a function. So I can write a function, let's call it my max. So this will take two things as argument, so let's call them a and b, and will return the maximum one of them. So let us write a little simple block. So if a is bigger than equals to b, you return a, else you return b. So as you can see, a function can have more than one return. So as you can see, a function can have more than one return statements, but in this case only one of them will be performed because they are inside an if else block. So let us try that. So let me print the maximum value of 3 and 4. So as you can see, it gives the right answer. Now this notation, you can probably guess what I mean by this. Oh sorry, I need to call my max and not the max that is inside Python. This still gives the same answer. Now this notation, you might guess what this does. So a function inside a function, so the innermost function will be executed first, as you can probably guess by the parenthesis. So first this function is executed, this returns a value which is then passed inside the print function as an argument, and then print does its job and prints it. Now let us talk about comments. So we are not done with functions yet, but don't worry, we are coming right after this. So comments are kind of like annotations, so they are not part of the program, not part of the program when it's running, but they are useful for the developer. So for example, let me just put it. So imagine this is a function and I want to have some extra information about it, so I can write a comment on top of it. So any comment starts with a hash sign. So I can write something like this. So I say this is a function. Now this whole thing is a comment. So it starts with a hash and goes until the end of the line. Now this thing is ignored. So if I try to run it, you'll see that it does not make any difference because this part is not read by the compiler or the interpreter, and it's purely for informational purpose. So if you are a developer, or if someone else is reading your code, then they might get stuck on some function. They might wonder, why have you written this? Then you can put a little comment there to explain your thing. Also sometimes we use to do, which is just a to do comment, which gives me some reminder. So for example, if I have to fix a bug, I will write a to do fix this. Now most of the text editors will automatically highlight your to dos so that you do not lose them. Now comment can start in middle of the line also. So you just have to remember, whenever it sees a hash sign, it creates a comment and follows until the end of the line. Note that, however, a hash sign inside a string does not matter. So if I have a string and I have a hash inside it, that does not create a comment. Now the comments, when the program starts running, the comments are actually stripped out because they are not exactly necessary in terms of running the program. However, there is another kind of comment which serves almost similar purpose, except it has something more. Let us see. So these are known as docstrings. So basically the full form is documentation string. So basically they are a string which is used for documentation purpose, generally after a function, to explain what a function does. So just after you have defined your function, in the next line you start a docstring by 3 quotes and close it with 3 quotes. So inside you can write an explanation for the function. So I can write it something like returns the max of 2 values. Now whenever I hover over my function, as you can see, VS Code is intelligent enough, so it reads the docstring and actually shows me an explanation. Now you have seen this before, so let's see. If I hover over this print, you will see that it actually prints what it does. So that information, it gets from its docstring. So this function has a docstring wherever it's defined, and most of your IDEs will actually parse your docstring and will show you a help. Now this docstring, unlike other comments, is actually retained when the program is running, and you can actually inspect this in runtime. We are not going to do that, however, but you have just remember that this is stored in the runtime. You can check the docstring anytime. Now in Python, functions are almost similar to your usual variables in the way that they can be assigned to some other variable. They can be stored inside another variable, or they can be passed as an argument to another function itself. So for example, if I have this mymax function, I can actually store it in a variable. Let's call it L, and then I can use this new name to call the function. So it works in the same way as you can see here, except that I can store this function in another variable. I can also pass functions inside another function as argument. So for example, let me write a function. So call it myFun, which, let's say, takes as argument another function and a number, and let's say 2 numbers, and then calls the function on these 2 numbers and returns the result. So now I can call this function myFun that I just wrote and pass it my mymax function and then 2 values. So what it does, it takes the first argument, which is a function, and applies it to the next 2 arguments and returns the values. So when I call myFun with these 3 arguments, it calls the mymax function with these 2 elements. Now there might be some cases where you want some argument to be optional. So the user can pass a value to it, but if they don't pass a value, you want to set a default value to it. Let's take an example. So let me create a new function, call it myFun. So it takes 2 values and returns the max of these 2. Now I want it to be like this. So if the user must pass the first argument, however he can omit the second argument. But as you saw before, if I pass 1 argument to a function that expects 2 arguments, it will give you an error. So how can I make it optional? So the one way to make it optional is by assigning a default value. So the way I can do it is, So I'll put something like this. So this means that if the user does not pass the second value, you can assume that it's 4. So let us see it an example. So if I print the function with 1 and 3, and then I print a function with only 2. So let's run it. So as you can see, it did not give me an error this time. So in the first case, I passed 2 values, 1 and 3. So it returned me the maximum of those 3. The next time I only passed the first value. So this means it automatically put 4 in the second value and then ran the rest of the body. So this time it returned the maximum value between A and 4, which is 2 and 4. So it gave me 4. So you can have as many optional parameters as you want. However, you have to remember that these optional parameters should be after all of the required parameters are written. So if I try to put it before A, I will get an error. So if I try to run it, I'll get an error which says that non-default argument follows default argument. So this argument is known as the default argument, and these are non-default. So you have to remember, if you want to have optional parameters or default parameters, you must put them after you have written all of the required stuff. Now let us talk about a few more types. So we have already seen types like strings, integers, and others. So now let us look at a few more types. So the first type is none. So the none object in Python, which starts with a capital N. So none represents an absence of a value, which means there is nothing there. So in other languages, this is generally called null. In Ruby, it's called nil. In Python, it's called none. Now I want to mention something in short. So I want to talk about truthy and falsy values. So you saw that in Python, when you write a condition, so if followed by a condition, so this condition should return a Boolean value, right? Now generally you can convert something that is not a Boolean to a Boolean by using the bool function. So you take a bool and pass it something like this, and it converts it into either true or false depending on what you just passed. So let me print it, and you'll see that it prints true, which means that this high string is converted into true. If I put an empty string here, you'll see that it converts to false. If I put 0 here, you'll see that it is also converted to false. If I put an empty array here, it is converted to false. And if I put none here, it is also converted to false. So the values or the objects which get converted into true are known as truthy, and whereas the values which are converted into false is known as falsy. So this tells you that none is a falsy value. Now we have seen how a function can return something. However, generally not all functions return something. So for example, I can define something like this. So a function that just prints hi. This function does not return anything. However, when you have a function that does not return anything, it actually returns none. So if you try to print it, you'll see that it actually returns none, as you can see here. Now we are going to do something that is very important in Python, which is known as a dictionary. So the dictionary is almost like a record. Like, so if you have, let's say you have a collection of students, so you have their name and their roll number, and you want the map between them. So for example, you want to know who has which roll number. So for roll number 1 you have a name, for roll number 2 you have a name, and something like this. So let me see an example. So let's say I want to have a record of marks. So dictionary starts with a curly brace. Now every dictionary has a key or some keys followed by some values. So keys are the things that you want to map, and values are the thing that you want them to be mapped to. So for example, here marks, I have marks of some students. So for every student I have a marks. So here students are the keys. So let me like this. So dictionary looks like this. So you have keys followed by a colon, followed by a value, and then they are comma separated. Now the keys need not be strings, they can be other things also, but I will talk about them later, what you can actually put as strings, put as keys. So here what I mean by writing this is that now I have a mapping between the name of the students and their marks. So I know James has marks 40, Hannah has marks 30, John has marks 20. So in case of lists, my keys were actually integers. So for position 0 I had something, for position 1 I had something, for position 2 I had something. Here in case of integers I am actually using something else, some strings. So for James I have marks 40, for Hannah I have marks 30, for John I have marks 20. Now I can use these values in the similar way in lists, so using square bracket followed by the key, and it will print the value of the key. Now you might ask, why did I put the names as key and marks as value? Why not marks as key and names as value? So the rule, what you have to remember is that you can obviously do that, but here as you see, you can only index by the keys. So if you put marks as keys, you would not be able to do this, because when you search for marks, when you look for James, it actually looks for the keys. So it looks through all the keys and tries to find where James is, and when you find James, it gets the marks. I hope that makes sense. Now if you try to use a key that is not in the dictionary, you will get an error. So for example, if I want to print this, so this is a key that is not in the dictionary, it will throw an error, which is a key error. Now just like lists, you can get the value out of the dictionary. Also you can reassign the dictionary, so I can change the value that is at the key to something else, and now I can print the marks. Sorry. So as you see, now it has changed. So it's almost similar to arrays. So except arrays implicitly have integer keys, whereas dictionaries has keys that you specify yourself. Now let us talk about what things we can put as keys. So the thing you can put as keys are immutable objects. So what are immutable objects? So immutable objects are something that cannot be changed. Now without going into too much detail, I can tell you that so far we have only talked about only two immutable objects. So those are lists and dictionaries. Sorry, these are mutable. These are only two mutable objects we have done so far. So it means that you cannot use a list as a key of a dictionary. So let us see how that will works out. So if I have a dictionary where I want to use a list as its key, I will get an error when I try to run it. So as you can see, it gives me a type error. It tells me unhashable type list. However, we can use anything else that we want. We can use our usual numbers, we can use floats, so this will still work, does not give any error. We can use strings, we can use other variables also. So for example, if I have a variable called, let's say 3, I can actually put L inside here. Let us print the dictionary and see how it looks. So as you can see, it puts the value of the variable and creates it. So just remember that you cannot put a list as a key or a dictionary as a key, but you can put them in values. So you can actually put lists as a value, or you can put another dictionary, also. So this also works. Oops, my bad. I am actually remembering JavaScript, so this actually works. Now what happens if I try to repeat a key? So here I have one key for L. If I try to put another key for L, as you can see, I do not get an error, but the first value of L is gone. So it's almost like assigning a variable. If you assign some value to a variable, the previous value is lost. A similar thing happens here. If you try to put two values, same values, so if you try to put two values in the same key, the first value will be lost. Now you can use the in operator and not in operator for dictionary also, just like you have done in lists. However, the major difference is that it actually searches for the keys. So if I do print A in D, this should print true because A is a key in dictionary. Whereas if I print 3 in D, it will give me false. Although 3 is a value in the dictionary, it is not a key. So you have to remember, when you use the in operator, it actually looks for the keys. So it looks for if that thing is a key or not. It does not search in the values space. Now, as you saw before, using a key that is not in the dictionary will give you an error. However, there is another method called the get method, which does something else. So let us see. So the way we call it is that we call the name of the dictionary followed by a dot and followed by get, and then I write the name of the key. So as you can see, it prints 1 because the value of the key A is 1, but it does something else. So if I use a key that is not present, it will give me none instead of throwing an error. In fact, I can actually pass a second argument here, which works as the default value. So if I pass a second argument, the way it works is that if the first argument is a key in the dictionary, it returns the value from the dictionary. But if the first argument is not present, it returns the default value. So this is very useful if you want to set some default value based on something in the dictionary. So for example, if you are making an app that the user can configure or set settings, so you can have some default settings, and if the user changes some settings, you can put it as a dictionary and then get the settings from the dictionary. But if the setting is not present, you can actually get a default value back instead of just throwing an error. Now tuples are very similar to lists, so at first glance they might look like almost same. However, there is a major difference. So let me show that with an example. So first of all, tuples can be created using the parentheses, and just like lists, you separate the elements with commas, and you can access the elements of tuple using the same syntax as list. So the numbering starts from 0 and goes on until the length of the tuple minus 1, as is usual in the case of lists, as you can see here. However, the major difference is that tuples are immutable, which means you cannot change a tuple once it's created. So if you try to change something, you will get an error, as you can see here. Also, you cannot add more elements to a tuple. So this is almost like a constant. So once you create a tuple, you cannot edit it in any way, which also means that you can use tuples as keys of a dictionary. So if you have a dictionary, as you remember before, you cannot use lists as the keys. You will get an error if you try to run it. However, you can use a tuple because tuples are immutable, and as you can see, it runs without any error. Now since tuples cannot be changed, it also means that it is faster than lists. So when should you use list and when should you use tuple? The rule of thumb is that you should use lists when you do not know how many items you have or you want to change some values later. But if you are sure about the immutability of the object you are dealing with, use a tuple. So if you know that you do not have to change anything, you do not have to add another item or remove anything, go with a tuple. Now here's something I want to talk about. So let's say you have a function that takes a tuple as an argument. So let me just print it. So assume that this should be a tuple. Now when I try to call the function with a tuple, so I can pass a tuple like this, so 1 2, and when I run it, it should print it. Now what happens when my tuple has only one element? So in that case I would write something like this. But you see, when I run it, this is not a tuple, this is just the single number 1. So this is because parentheses, if you put a number inside a parenthesis, this just means the usual arithmetic of the parenthesis. It will just evaluate the number 1, which is not what we want. So if you want to create a tuple with only one element, you have to put a trailing comma. Now when I try to print it, you will see that it is actually a tuple. So remember that if you want to create a tuple with only one element, you should put a comma after the single element. Otherwise it will be just one single element and not a tuple. And just like empty list, you can have empty tuple by using an empty parenthesis. This will create an empty tuple. Now we are going to look at list slicing. So list slicing is, as the name suggests, slicing a list. Well, it means that you, instead of getting one value back from the list, you are getting a number of values from the list, or a values between a range in the list. So for example, all the elements starting from the first item or the first element to the fifth element. So let me show that with an example. So for example, let's say I have a list of 10 elements. So the basic way of list slicing is by using two colon separated integers. So if you remember the range function, so the syntax, although the syntax looks different, but there are some similarities. So for example, let me see. So the way it works is that you write the name of the list and square brackets, so as if you are going to get one element, but instead of writing one index, you put one index and after a colon you put the next index. So this is similar to the range function. This means that start from the 0th element, go on before the 8th element. So this means starting from 0 up to 7. So 0 1 2 3 4 5 6 7, so it should print up till 8, as you can see here. So if I change it to 7, so this prints only one element, so it starts at the 7th index and goes up to 7th. So just like range function, the first index is always included and the next index is always excluded, so it goes before the next index. Now you can omit one of these two or both of them. So if you omit the first number, it is taken as the start of the list. So if you do not write the first number, it means you are starting at the 0th element and going until whatever is here -1. And if you put the first number but omit the second number, this is taken as the end of the list. So this will start at index 2 and go until the end of the list, as you can see here, up to 10. And if you omit both of them, this is taken as the start of the list up till the end of the list, or this is basically just a copy of the entire list. Now just like range function, list slices can also have a third integer, which, as you might guess, is the step. So this means we start at the index 2, go up to index 7 and with a step of 2. Oops, like this. So we start at index 2, go at a step of 2 and up to the index 8. So this is just similar to range function. So if you remember range, you remember this, or you can understand this. Similarly, in this case also you can omit the first number, which means that it starts from the start of the list. You can also omit the second number, which means that it starts from it goes until the end, or you can omit both, which means it goes from the beginning to the end with a step of 2. Now you must remember, if you must put the colons. So if you are not interested in putting a step, you can just omit the step along with the colon itself. Or if you want to put the step but do not want to specify any starting or ending point, in that case also you should put those 2 colons, otherwise it will not work. Now if you remember, in your list indexing we saw that we can use negative integers. So if I use a negative integers, the counting starts from the end of the string. So here also, in case of slicing also, we can use negative numbers. So for example, like this. So in this case it means that when I use a negative integer, it means that the counting is done from the end. So -1, as you might remember, means the last element of the list. So this starts from the index 1, which is this number, and goes before the last element of the list. So it should go up till 9, as you see here. Now I can also use this also. Oops. So -3 means the third element from the last. So it starts from the -3th element and goes until the element at -1 position. You can see here. So this is the third last element, and it ends before the last element. Now you can also use negative integer for the step numbers. So if you use a negative integer as the step number, the slicing is done backwards. So let me put things like here. Something like this. So as you can see, it gives me an empty string or empty list, because it will start at this position and go backwards until it reaches 5, which it cannot. So in this case I have to switch the order, just like the range function. So if my step number is negative, the first integer should be bigger than the second one. So now as you can see, the slicing has been done backwards. Similarly, if I put -2 here, the step will be 2, but in the reverse way. So if I omit the first and second numbers both and put -1 here, so this means that it will start at the end of the list, go up to the beginning of the list, and at a step of -1, which means it actually reverses the list. So this is one trick to reverse the list without modifying the original list. Now you all must remember that slicing actually creates a copy of the list, or copy of the part of the list. So it actually does not modify the original list. So as you can see, the original list is still intact. Here I just made a copy. Now slicing can also be done on tuples, but they are mostly used in list. Now we'll look at a very powerful feature of Python known as comprehension. So we'll see list comprehension and dictionary comprehension. So list comprehension is a very fast way to create a list where the elements follow a certain rule. For example, let's say I want you to create a list that contains all the squares of all the numbers from 1 to 10. So you might do something like this. So you start with an empty list and then loop. So for I in range 1 to 11, this means we start at 1 and go up to 10, and we append the square of I, and finally I print the list. So if I run this will give me the square of all the numbers. So in this case, you see the elements of the list follow a very simple rule. So I have some kind of range, or I have something to iterate over, and for every element of that thing I have a rule that gives me one element of the list. So this thing can be shortened by using a list comprehension. So the syntax looks like this. You put a third bracket or a square bracket as if you are going to write a list, then you write this. So what this does, so you have this thing, a rule followed by a for loop, or the first line of the for loop. So my goal is that, or my requirement is that I have something to iterate over, and for every element in that thing I have a rule that gives me an element of the list. So this is how list comprehension looks like. So it almost reads like English. So I square for I in this range. So for every element in this range, I take it as I, and I take I square, and this I square will become the element of my list. So if I print it, you will see that it does the same thing. So it iterates over this range, it puts it in the value I, and then takes its square. So this is very simple. Now you can also have some kind of condition over it. So for example, let's say I want to say, or I want to create a list with squares of every integer who are even. So 2 square, 4 square, and so on. So I can put an if condition after that. So if I %, so if I is even. So this if will put the element in the list only if this if is true. So it will iterate over this thing, take every element in I, and calculate this if statement. So if this if condition is true, only then it will calculate this rule and put the value in a list, otherwise it will skip it. So as you can see here, so only even numbers. So this is very useful if you have one list and you want to transform the elements of the list into another list. So for example, if you have one list and you want to square all of the elements. So for example, let's see. So let's say I have a list. Oops. And I want to square all the elements of this list and create another new list. So I can do like this. So I square every element where every element is actually in L. So it will iterate over this list L, take every element in I, square it, and put it in list A. So if I now print the list A, you'll see that it contains all the squares of the numbers in L. As you can see here, 9, 25, and 36. So this is very useful if you want to quickly create a list from another list or another range or anything. Now just like list comprehension, we can also use dictionary comprehension. So the syntax is almost similar. However, the first difference is that we use curly braces just like a dictionary. And in this case, I have to write the format in a key : value format. So something like this. So the right side of it looks the same as list comprehension, but instead of just putting the value, here I have to put it in key value pair. So it iterates over this range, it takes every element in I and makes I a key and I square as value. So this should give me a dictionary where the numbers are the keys and their squares are the corresponding values. So like this. So 1 is 1, 2 square is 4, 3 square is 9. So the syntax is almost same as list comprehension, except that I have to write it in a key value pair. Now imagine you have this code. So let's say you ask the user to enter two numbers. So for example, like this. So let's say you have a number So for now I'm just prompting the user with just this thing, and now you want to print their quotient. Now if I run it, so let me enter the first number and let me enter the second number, and you will see that I get the quotient back. However, what happens if I enter the second number as 0? You will see my program crashes. It shows me an error, 0 division error, and it crashes. Now there can be some other errors. So far we have seen quite a few errors. For example, if your list has only 4 elements and you want to access the 5th element, you will get an index error. If you try to access a dictionary with a key that is not present, you will get a key error. If you try to change a value in a tuple, you will get a type error, and so on. But in all the cases when the program encounters the error, it just crashes and stops. So how can we handle the error so that if the program encounters an error, it can recover from the error? So here we use something called try except block. In other languages, this is generally called a try catch block, and here we call it the try except block. Now the syntax looks like this. So you have something called try followed by a colon and after indentation. So in this part you write code that might give you an error, or that might throw an error, as we call it in programming terms. So for example, here you might put something where you potentially will divide by 0. So I'm not saying that this code will always give you an error. I mean, here you should put something that might give you an error. For example, trying to read a file that does not exist, or something like that. So here I want to put something simple. So let's say, let me just put the previous code. Let me just copy it back. So this part. So I'll put this part in a try block. Oops, why did you do that? So in this part I write program that might crash. Now after I'm done with the try block, I put a except block. So the syntax is except followed by a name of the error that might occur here. So I know that I am dividing by something. So in this case I probably will have a 0 division error. So I will write 0 division error, and now here I write the code that will be handled. So let me just print divided by 0. So the way it works is that, so the program will try to execute this part normally, but as soon as it encounters an error, it will jump to this except part, only if that error matches whatever is inside this error except. So let me print another line. Now let us first try to run it. So now if I run this normally, as you can see, it does not execute the except block. So I have the result of the division and it prints end. This part is not executed. This part will only be executed if there is an error. So let's now put an error. So if I put a 0, as you can see, it jumps to the block, jumps to the except block. Now as you noticed here, this thing is not printed, so which means this line gave an error, the division line, this gave an error, and as soon as it gives an error, the control jumps to this except part, and whatever was after that is not executed. So it's almost like returning from a function. So if you would write something that is after the return statement, that is not executed, right? So in this case also, as soon as a program encounters an error, it jumps to this corresponding except block. Now what happens if there is some another kind of error? So for example, it wants a number, I put a string. So as you can see, it crashes this time with a value error. So you see, this except block is not encountered. Why is that? Because this except block only handles a 0 division error and not a value error. If I want to handle value error also, I have to write another except block. So here I can print value error. So now if I give the value error again, you will see this time it handles. Now one except block can also handle more than one exceptions. So for example, let me remove that. So in that case I have to put it in a parenthesis, oops, followed by a comma, almost like a tuple. So let me write it divided by 0 or a value error. So this time this except block single-handedly handles these two errors. So now as you can see, if I make a 0 division error, this except block is executed, and it is also executed if I give a value error. However, it is generally not a good idea to have one except block handle multiple errors. I mean, it only makes sense if you do not want to care about what kind of error occurred. Otherwise, if you want to know what kind of error occurs and you have particular strategies for recovering from that kind of error, you should put them in different except blocks. Now finally, so as you saw here, this actually forces you to think about what kind of error there might be when you run a program. But if you do not want to deal with it, you just want to handle all kinds of errors that might occur, you just do not write anything after the except. So here this except block will catch everything. So any kind of error. So does not matter if it is a 0 division error or it's a value error or something else. But this is a very bad practice because it might hide programming mistakes or some logical errors. So you should use this very sparingly. Now try except has one more partner who is optional, which is a finally block. So a finally block is executed no matter what happens. So if your program does not throw any error inside the try block, it jumps to the finally, and if your program throws an error, it executes the except block and then goes to finally block. So this block is always executed. Even if your program does not throw an error, it is executed. Even if the program throws an error, it is also executed. So let us see. So first, the program does not throw any error. So as you can see, the finally block is executed. Now second, if the program throws an error, in that case also the finally block is executed. So it first tries to execute the try block. If it does not throw an error, very good, it jumps to finally. If it does throw an error, it goes to the except block, it handles it and comes to the finally block. So the finally block is always executed, it's no matter what happens. Now what happens if there is some error that is not handled inside the except block? Will the finally block run in that case also? Let us see. So let me put a 0 division error. So this time I am only handling the 0 division error. So what happens if some other kind of error happens which I do not handle? So for example, a value error. So as you can see, the finally block is actually executed, but the error is thrown after that. So in this case, you see when the error occurred in this line, so in this case I actually entered something that is not a number and tried to convert it into a number. This threw a value error. However, I am not catching the value error, or I am not handling the value error. So it executes finally block and then throws the value error. So as if it keeps the error in a closed in itself. So when it encounters the error, it first looks for the except block to see if anyone will handle it or not. So nobody handles it, so it keeps the error to itself, then executes the finally block and then throws the error. So if you have an uncaught exception or an unhandled exception, in that case also you can be guaranteed that this finally block will always run no matter what. So this is very useful if you want to do some kind of cleanup. So for example, you are reading something from a file and you want to close the file. So if the reading successfully happens, you close the file in the finally block, and even if some kind of error happens, you handle the error and then close the file here, which is a very good practice. So some kind of cleanup works are generally used in the finally block. Now we can also throw errors ourselves. So if I have a program that requires some kind of input and the user does not give proper input, so I can actually decide to handle the input myself, or I can decide to throw an error. Even my functions can also throw an error if I want. So the way we do it is by using the raise keyword. So it is like this, raise followed by a name of the error. So for example, let me throw a value error. So when I run this program, you will see that it just throws a value error. It's just nothing else, does nothing else, just throws a value error. So I can also pass arguments to give more information about them. So let me just write a message here, and when I run it, you'll see that the message is shown here. Now I can also use raise syntax. So inside an except block, so if I have an except block, I can just use a raise without any name of the error, and this will rethrow the error that happened here. So if a zero division occurs, it will execute the except, and when it sees only the raise statement without any name of error, it will throw whatever error caused it to come into the except block in the first place. So if not that's not what I wanted to do. So if I run it now, if a zero division error occurs, you will see it first executes the except block and then throws the same error once more. So far all the codes we have used, we have written our own code, but now we are going to look at modules. So the modules are basically a code. Generally it can be a code written by someone else that I can use in my code, or maybe it is a code that is written by me and it's now in a different file. Let's say file for now. So I have some code that is in a different file for organization purpose. I mean, for structuring our code, it is a good idea to separate related parts into separate files. So if I have some code that is in a different file that I want to use in my another file, how can I do it? So for that I will use the import syntax. Now in order to use a module, you have to know the name of the module. So for this example, let's say I want to use the random module. So the random module is a module that is already written by the developers of Python, which is a part of the Python standard library. So it contains code related to randomness. So we'll see. So the way we do it is by using import random. So import followed by the name of the module, and now I can use anything that is inside this random. So inside a module I can have functions, I can have variables, I can have classes and other things. So let's say I want to use the randint function from this random function, which generates a random integer. So let us see how we can use it. So in order to call a function from this thing, I have to write the name of the module followed by a dot and followed by the name of the function. So the name of the function is randint. So this takes two arguments, let's say 1 and 10, and generates a random number between these two. You'll see it generates a random number. So if I run it once more, it will generate something else. I like that. So in order to call the function, I have to first put the name of the module followed by a dot followed by the name of the function. Now what if I want to import only a single function from the module? So in this case, when I do import random, it actually imports the entire module in my code, so which might be excess for me. So for example, let's say if I want to use only the randint function, I do not need anything else. So how can I do that? So in this case the syntax looks like this. I will write from random import randint. So from followed by the name of the module followed by import followed by whatever I want to import. In this case, as you see, this gives me an error because the random module itself is not imported, only the randint function. So in this case I do not need to write this. I can use the randint function as if I have written the function myself. So if I now run this, I will get the same thing. Now if I want to import more than one things, I can just put comma and write their names. So now I have imported two different functions, so randint function and randrange function. So in this case you can also import anything you want, or if you want you can actually import star, which will import everything else. Now this is generally discouraged, so let me just talk about why. So for now, let's say I have only imported randint. Now let's say, suppose I have a function called randint that I have written myself. So this also takes 2 arguments, and for now let's say it prints this is my function. Now I have a function called randint, and I have also imported a randint. Now what will happen? So if I try to run it, as you can see here, instead of running the randint function from the imported module, it actually runs my function that I have written here. And it also shows me an error, function already defined. So this means when you use this syntax from module import this syntax, whatever you import, it becomes as if you have written it. As you can see here, we do not have to put random dot randint, we can just use randint as it is. But if you have something that has the same name as what you just imported, the thing that you wrote will overwrite what you imported. So if you have a function called randint, your function will take priority over what you imported. This might cause confusion. So for that, you should not use this star syntax, because it will import everything in that module from here. Now if you have a variable and the module also has a variable with the same name, your variable will take priority, and this might break the functions of the module. So if the randint function depends on some variable, let's say x, which is inside this random module, and you also have a variable called x, then the randint function will actually take your variable, and this can cause confusion. So this is very bad program, and you actually, as you can see here, I have so many imports that I have not using at all. So this is actually discouraged. Now how can we mitigate this error? So for example, let's say I should have a function called randint. I cannot delete the function that I have written. I can also not delete this import. I have to use both. So how can I distinguish between what I have written and what I just imported? So in this case, I can actually write as followed by some other name. So what this does, this basically renames this function. So this renames the randint function to ri. Now when I write randint, it actually uses my randint, and when I write ri, it will actually use the thing that I just imported. So as you can see here, so first one calls my function and the second one calls the imported function. So this is very useful. If you have something with the same name, you can actually use this thing to rename it. Or maybe if the name of the function is too long, you can actually rename it to be something shorter. Now if you try to import some module that is not available, you will get an import error, which you can actually catch using a try except block. This module not found error. Now Python has quite a large number of pre-written modules. So you have modules to work with strings, module to work with time, modules for math, module for interfacing with your operating system for system purposes, etc. So it has a large number of standard modules. Also you can actually install new modules. However, we are not going to talk about how to install modules. You can use the pip command, but we are not going to do that in this video. So this is the final part of the video. In this part, we will do some basic file handling. So we'll just open files, read and write them. So in order to open a file, you use the open function. So you write open followed by the name of the file. Now you must write the full path of the file. Now I assume you know about the paths of a file. I'm not going to detail about it. But if the file is in the same folder as your program, you can just specify its name. So let me write something called test.txt, and you can store it in a variable. This opens the file. Now if you look at my folder structure, you will see that there is no file called test.txt. But if I run the program, you will see now that this shows an error because the file does not exist. So let me just write some file name that is actually present, or maybe let me just create a file. So I am creating a file called test.txt. Now if I try to run it, I will not get any error. So this actually opens the file. So by default it opens the file in read mode, which means you can only read this file and not write the file. But we can actually change it with the second parameter to the open function. So this should be a character. So if I pass R, it means open the file in read mode, which is the default. If I pass a W, which means open the file in write mode. In this case I can actually write from the file but I can't read from the file. I can put A to open the file in append mode, which means I can add some stuffs to the file. So just to be assured, so when you create a W, open a file in W mode, write mode, it actually deletes the entire content of the file. So let us see with an example. So let's say I have a file within the test.txt. Let me write something here. So in my test.txt file I have written ABCD. Now if I open the file in write mode, so this opens the file in write mode and closes it because I have not done anything yet. Now if I read the file again, you will see that it is empty, because when you open a file in W mode or write mode, it actually deletes whatever was inside the file. So if you do not want to do that, let me write this again. So I have written ABCD once more. So if you do not want the program to delete everything from a file, you can use A or the append mode. Now if I run the program, you will see that it has not deleted whatever was there. So append mode means you will write things at the end of the existing parts. So whatever is existing will not be deleted. The new things that you write to the file would be added after the existing part. Now you can also use the mode called B, which opens the file in binary mode, which is useful for files that are not text, generally sound or image files. You can also use WB to write a file in binary mode. And finally, if you want to open a file in read and write mode, you can actually use R+. So from this file you can actually read a file and also write a file. Now if you try to open a file in write mode that does not exist, for example let's say test2.txt, you actually do not get an error. In fact, you will now see that it creates a new file. So if you use the W mode or the write mode, in that case you need not worry about existing file. So if the file does not exist, W mode will create a new file, and if the file exists, it will delete everything in the file and start fresh. And finally, once you are done with the file handling, you can close the file by calling the method close on it. f.close will close the file f. Although your file is automatically closed when the program exits, but if the program runs for a long time, it is not a good idea to keep the file open. Alright, now let's read a file. So let me read the test.txt file. So I will open it in read mode. So let me first put something in a file. So I have ABCD, let me write something else. XYZW, that makes sense. So now my file has two lines, ABCD and XYZW. So let's see how I can read it. So first I will open it in read mode, and then I can use the entire content by calling the read function on this file. So f.read. Now I can store it in a variable. Let's call it content, and let's print it. And as you can see, it prints the entire content of my file. So it reads the whole file and prints it. Now if you do not want to read the entire file in one go, you can actually pass a number to the read function. So for example, let's say I pass 2, which means it will actually read the first 2 bytes from the file. Now remember, this does not read the first 2 letters of the file, this reads first 2 bytes of the file. Now letters are actually 1 byte, so in this case 2 bytes means 2 letters, but if you have some letters that take more than 1 byte, for example some Chinese letter or Japanese letter, this will actually read the first 2 bytes. Now let me just put this in a print statement here. So once I have read 2 byte, I can make another call to the read function. So read 2 once more. Now you'll see that it actually reads the next 2 characters. So once you call a read, you can imagine that the program puts a bookmark in the file, how much you have read. So when I do f.read2, I read 2 bytes, and after 2 bytes I put a bookmark. And when I call the read function again, it starts reading after that point. It does not start reading from the beginning of the file. It actually starts reading after whatever you have written. So this file actually has a cursor here, which moves, and you always start reading from the cursor. So when you read first 2 bytes, the cursor moves to the next byte. So when you call the read function again, it reads then from that point and not from the beginning. So I can call another read once more. So for example, let's say another 4 characters. So as you can see here, first read reads 2 characters, second read reads 2 characters, third read reads 4 bytes, so 1 byte is the new line character, and the next 3 bytes. Now if I do not pass anything to the read, it will return the rest of the file. So as you can see here, first read reads 2 bytes, next read reads another 2 bytes, the last read reads the entirety of the file, whatever is left. Similarly, if you pass a negative value, it will also read the entire content of the file. Now once we have read until the end, if I try to read again, I will get an empty string, as you see here. So here I have an empty string. So this is because, as you saw, as I said before, this file has a cursor. So once I have read the entire file, the cursor is now at the end point and there is nothing else left to read. If you do not want to read byte by byte, you can actually read line by line. So the way you can do that is by using read lines. So file followed by the read lines. So this reads the file and separates it into lines and creates a list of all the lines. So if I now print it, you will see that it takes each line and puts them in a list. So now I have a list of all the lines, and now this is a list and I can iterate over it. Now you can also use read line. This actually reads only one line, and now just like read function, I can call it again and it will read the next line. As you see here, now this, as you can see, there is one extra new line character. So the reason is that this ABCD, after the ABCD there is one new line, as you saw here. This new line comes from the file, whereas the next new line comes from this print function, because print automatically adds one new line to it. So in essence there are 2 new lines, although in the file there is only one new line, but the print function adds another new line while printing it. So that's why there is one gap between them. So read line behaves like read, it reads one line each, and if you want to get all the lines, you will use the read lines function, as you saw, which returns the list of all the lines. So you can use it in a for loop to iterate over all the lines in a file. Now finally we will write to a file. So for writing to a file, we have to open it in W mode. So this will delete everything in the file. Now once we have opened it, we will use the write function. We'll use the write function and pass it a string. And once I run it, it will write the string to the file. Now if I read the file, you will see it now has hello. Now you can use multiple write calls. So now you will see that it starts writing just after the end of whatever you have written. So it writes hi just after hello, which also means that after writing hello, it does not insert a new line character, which is good. Now if you want a new line, you have to put it yourself. So put a new line yourself. Now when I read it, you will see that there is a new line. Now write actually returns a value. It actually returns how much bytes you have written, so I can actually print the result of the write function. So let us print this, let us print this. So now when I run it, you will see it returns 6 and 2, so which means the first write actually wrote 6 bytes, so 5 bytes for hello and 1 byte for the new line, and the second one wrote 2 bytes to the file. Now as I told you before, that if you want to open a file, it's a very good idea to use a try and finally block, so that if an error occurs, your file is always closed. So you will write whatever you want to write. So this thing will actually be written in a try block. And this close part will actually be written in a finally block, which is the best practice, so that you guarantee that your file will be closed even if an error occurs. But there is a shortcut way of doing this with Python, which is use the with block. So you write this with followed by this open statement that you just wrote. So test.txt w, let's say, followed by as, and then a variable name. So let me call it f. So this opens the file and puts it in a variable called f. Now you can write something like this. So I can do whatever I want with it. So I can write things like this. Now as soon as the with block ends, the file is automatically closed. Even if an error occurs between here, this file is automatically closed. So instead of writing big try finally blocks, you can actually use this with block and be assured that your file will always be closed even if an error occurs. So that was everything for this video. So here we started by installing Python, and we learned data types, we learned integers, numbers, strings, we learned functions, lists, dictionaries, tuples and files, exceptions, loops, if statements, and quite a lot of things. If you like this video, smash that like button, smash that subscribe button, comment your suggestions down below. I might do a video on advanced Python in future. So do not forget to stay subscribed and hit the bell icon so that you do not miss any future updates. Thank you.